64. Use a graphing utility to graphically solve the equation, approximate it to 3 decimal places, and then check your answers algebraically. So I'm going to do that backwards. I'm going to work it algebraically, and then I'll work it graphically to see that we get the same thing here. So this is not quite in the format of exponential form or logarithmic form, but I could undo this times 6 with the divide 6. And now it's in the exponential form. So if I switch that to logarithmic form and these two switch places, it look like that. Now optional, but kind of a good idea. Instead of saying log base e, we should probably just say natural log. And then we need to, looks like we need to subtract a 1 over and multiply both sides by a -1. So that is what I would say would be my exact answer. This one specifically asked me to round it though. So if we put that in our calculator, that is approximately -0.427. Okay, and then they want us to check it graphically as well. So to do it graphically, what you should do is graph both sides. Actually, I'm just going to graph one. Okay, so there's the left side, and then I'm going to subtract the 25 over. So now I'm interested in when this equals 0 because I'm subtracting the 25 over. And based on my algebra work, what was that? I don't remember the decimal. It was about -0.427. So when I look at the graph, it should be right about there. That's good news. But if you are only approximating with your calculator, you need to try to get your cursor on this where it equals 0. And just hitting trace is not quite close enough. So if you hit second trace, it brings up this calculate menu, which is good for finding a lot of stuff. You use this menu quite a bit in calculus. But number 2, find a 0. It's going to want you to hit enter when your cursor is a little bit to the left of your x-intercept. Oops. I hit enter twice. Okay. Enter for left bound, then you got to move your cursor to where it's to the right of the x-intercept you're trying to find, right bound, and then hit enter to skip guess, and then it will bounce that cursor back and forth until y equals 0, and it's -0.427. Which is what we got algebraically. So they're just trying to make that connection for you.